Hi, welcome to our channel of IGNOU audiobooks, Indira Gandhi National Open University. School of Education, SOE. Certificate Programs. Certificate in Elementary Teacher Education for Tripura State, CETE. Optional Courses. MESE 01 to Teaching of Science. Block-1 Instructional Planning and Evaluation in Science. Unit-1 Science in School Curriculum. 1-1 Introduction. Science is the word for modern age. This word is an inseparable part of modern life. What is science? What is so special about it? Why do we teach science to our school? Children? What do we teach them in the name of science? These are the basic questions to which a science teacher must know the answers for. You have decided to become a science teacher, so you should know all about science. This unit will help you understand the nature of science, the purpose of teaching science, and objectives of teaching science for the cognitive, affective, and psychomotor development of human abilities. You will also learn about the science curriculum and its place in school education. This unit also provides for the recording of your own observations and experiences as you move along with the unit. Towards the end of each part, some assignments have been framed for you to recapitulate what you have learned. The summary of each part is given at the end of each part. At the end, some references are suggested for your further consultation. 1.2 Objections. After going through this unit, you should be able to describe the nature of science in your own words. Identify the components of science. Describe various processes of science. Establish a relationship between the type of knowledge acquired and the process used for acquiring it. Identify the components of scientific attitude. Classify objectives in cognitive, affective, and psychomotor domain. Write down the objectives in behavioral terms. Describe various principles of curriculum and construction. Examine different approaches for curriculum development. Justify the place of science in school curriculum and describe the salient features of the school curriculum. 1.3 Nature of science. 1.3.1 What is science? We will not give you any standard definition of science as given by scholars nor the definition given by scientists. Instead, we will help you to define science in your own words as you develop an understanding of science. Human beings are curious by nature. They have a highly developed mental ability which help them to observe precisely, correlate observations, and predict future happenings on the basis of these observations. This ability has helped human beings to adjust to nature. They explore, interpret, and change the physical world according to their own need and requirement. The process of observing, describing, exploring, and using the physical world is nothing but science. Suppose Anil says all insects have 3 pairs of limbs. If this statement is Anil's own observation, then we will say that Anil is learning science. What are the sequences after which Anil has given this statement? Anil saw an ant moving on a wall, and while observing its movement, his attention was diverted to its legs. On another occasion, he saw an housefly and his attention was drawn on its legs. Anil was amazed to note that it also had the same number of legs as that of an ant. In this way, Anil's instances of observing insects goes on increasing, and he come to the conclusion that all insects have 3 pair of limbs. The first observation could be a chance observation, but once he realized the similarities, his further observations became more intentional or selected. There was some element of curiosity involved in Anil's second observation onwards. During the intentional Observations. Anil might have observed other creatures also which he kept in other categories. He could have retained his attention only on insects, and that too on the part of body responsible for locomotion. Anil is learning science, which is a lengthy and continuous process. Let us see what is this process. 1.3.2 Science as a process. Process and processing are the words we often use in our day-to-day conversations. In teaching profession alone, the word process is extensively used, such as admission process, teaching process, learning process, process of socialization, examination process, and evaluation process, etc. Any process may involve the following activities: steps to accomplish a task, ways of doing work, planning for various stages of an activity, and establishing systematic steps for gathering and retaining information. In science, the way of gathering information, thinking, measuring, solving a problem, or in other words, the ways of learning science are called the processes of science. Let us reconsider Anil's observation leading to his statement all insects have three pairs of limbs. First of all, Anil became aware of various insects in and around his house, saw some ants carrying sugar cubes, become curious about their activity. Then, he by chance observes the limbs, legs, and counts them. Intentionally observes housefly, mosquito, and other small insects in and outside home. Observes common characteristics of insects, especially limbs. Draws inferences, and makes a statement. Basic processes or basic processing skills. Anil has employed two basic skills here. 1. Observation and 2. Inferences. Above two skills are called processing skills because they are used to apply processes. Let us discuss other skills. I. Observation. You must be clear by now that observation is not just seeing or looking at, or glancing, or viewing. During the time we are awake, we see or look at various objects and phenomena around us. The regularity in viewing these phenomena or objects catches our attention, and that becomes observation. We see flying birds, rain, cloth drying, water boiling, or different varieties of plants, flowers, animals, etc. The foremost process skill we use is observation. It is through observation only that we know our environment, physical as well as social. We observe natural phenomena, objects, plants, animals, and human beings and learn about their nature and behavior. What do you do when you first observe a thing? You look for its characteristics, and on the basis of these characteristics you classify it into a particular category. 2. Classification. During classification, you may group distinct objects in one group on the basis of similarities which various objects share, for e.g. textbooks, reference books, novels, story books, etc. are grouped together under the category or class of books. Similarly, other class of insects, flowers, acids, carnivorous or intelligent people, etc. 3. Communication. For representing a class of objects we need some name, label, sign or symbol, etc. These labels and signs communicate the information about the class members. Communication is an important skill in transmitting and testing the knowledge. For recording and communicating the information, especially in science, we also need the skill of measurement. 4. Measurement. Measurement is used for recording precise and accurate observations. For example, rise in temperature, change in dimensions, change in dimensions, change in duration, etc. 4. Recording such observation, various scales and instruments could be used. Selection of the instruments depend upon the degree of precision or exactness required in the measurement. Estimations. Sometimes, we do not require such accuracy there we can use estimation e.g. half a glass of water or 1/4 of a piece of bread, a bunch of flowers, etc. On the basis of the acquisition of the aforementioned skills one can peep into the future. While planning activities skill or prediction is required. 6. Prediction. When you observe dark clouds in the sky, what do you say about the weather? If you have to go out, you may have to take an umbrella. Why? Because you have predicted the weather. Prediction is the skill which helps us to know the behavior of any particular object or phenomenon before it happens. All our planning depends upon prediction. Prediction about eclipses, crops, weather, behavior of substances of human beings are some instances. If you are able to predict various phenomena on the basis of your experience and observations, you can also explain it. To explain the phenomenon, you should be able to relate various facts properly. This ability of establishing relationship between various phenomena or facts is the ability of generalization. Inferences. The abilities of prediction, explanation, and generalization together from the process of making inferences. The quality of knowledge acquired by an individual depends upon the quality of basic skills applied. Sharp observation will lead to sound and accurate knowledge. As the mind grows with age, the complexities of the processes also increase. Several skills functions together and help the child to interact and adjust in his physical and social environment. Integration of skills help an individual to answer why, when and how type 2 questions. To get an answer for why, how we have to conduct an experiment. Experiment is an coordinated activity as you have to take measurement, set up an experiment, etc. These skills are called integrated skills. Let us how discuss them. Integrated skills. Various skills that are required to carry on an experiment successfully or to solve a problem are known as integrated skills. When an individual is confronted with a problem, then he first looks for the nature of problem and its relationship with the whole system. Suppose you want to dissolve some solid substance into a given amount of liquid to make a solution, and you wonder as to how much solid could be dissolved in the liquid. Now, the process of making the solution depends upon the nature of the solute, nature of the solvent, and the temperature. These are the variables of the system. Here, system can be designated as the solution. We shall discuss the skills required in the following pages. Identifying and controlling variables. In science, we study the effect of one variable over the other. For example, if you want to study the effect of praise on the achievement of your students, the first variable, i.e., praise, will be called the independent variable, and the effect of this variable on other variable, i.e., achievement, which is called the dependent variable, but there are other factors such as age, intelligence, fatigue, etc., which might affect the achievement, but these variables have to be controlled or kept constant. 2. Defining operationally. Whatever information individuals acquire through experiments, observations, or experience, they use it to describe in meaningful statement is the phenomenon, object or event, etc. 4. Example, the solubility of a substance in a given solution increases with the increase in temperature of the solution. 3. Forming hypothesis. We have already discussed the meaning and importance of prediction. Statements of predictions are also called the hypotheses. It denotes the conditions in which future happenings are expected. As these statements mention the conditions for prediction, they are said to be more formal and controlled scientifically. Hypothesis makes a guess about the expected outcome of an experiment. 4. Experimenting. Experiments are conducted to test hypotheses. Designing and conducting an experiment requires the use of many skills. During the testing of a hypothesis, we study the effect of independent variable on the dependent variable, keeping other variable under control. Tabulation or graphing. During the experiment, the investigator collects information in an organized way. The information can be represented clearly in the form of tables or graphs. 6. Interpreting data. The information received or the knowledge gained through the study of data help the investigator to test the hypotheses or form conclusions. You can study the table and conclude that amount of solute dissolved in 1 liter of solution increases with rise in temperature, or the volume of a gas decreases with rise in pressure. 7. Investigating. In order to solve a problem, pupils are required to observe, collect, and analyze that data in order to form meaningful conclusions. All the above mentioned processes help the learner to discover meaningful information and take decisions. The systematic and organized use of the above mentioned process skills help people to understand and adjust to their physical and social environment. It is through these processes that students can learn to unfold the mysteries of nature, which in turn helps them to use nature according to their own needs and requirements. According to Dr. D.S. Kothare, to learn science is to do science. There is no other way of learning science. Science is a systematic process of learning. 1.3.3 Science as a product. Whatever information or ideas we acquire through various processes of science form the body of knowledge, also referred as products of science. Solution to every problem leads to the discovery of a new problem, and the cycle goes on, and the result is the accumulation of knowledge. The basic components of knowledge are facts, concepts, principles, and theories. Facts. Facts are specific, verifiable pieces of information obtained through observations and measurement. They are verifiable with reference to time and place, e.g. 15 students attended the class on 7 July 86 at 10:30 am. Some facts do not require the time and place to be mentioned, e.g. iron is a grayish hard metal. Some facts are specific, like water boils at 100 oC at 760 millimeters of pressure. Water is a liquid. Solids have definite shape and volume. Birds fly, etc. are the other examples of facts. Concepts. Concepts are abstract ideas that are generalized from facts or specific relevant experience. Concepts are single ideas represented by single words, e.g. chair, books, acids, flowers, honesty, democracy, students, etc. According to Brunner, every concept has five elements, viz. Name, example, positive and negative, attributes, characteristics, attribute value, and rule, definition. Principles are more complex ideas based on several complex concepts. They are the rules on which the activities or behavior of things depend, e.g. Pauli's exclusion principles, of Boss principle rule, Hans rule, etc. Theory. Broadly related principles that provide an explanation for phenomena are known as theories or laws. These are used to explain, predict, and relate various facts and phenomena. Theories confirmed by various scientific experimentations by scientists over a period of Time become laws. The relationship between various components of the product is shown in the following diagram. Facts up towards concepts up towards principles up towards theory up towards law. 1.4 Objectives of teaching science. Education is a process of bringing about changes in an individual in a desired direction. It is a process of helping a child to develop his potentialities to the maximum and to bring out the best from within the child. To bring about these changes, we teach them various subjects at different levels of school. Science as a subject is included in the school curriculum from the very beginning. Before taking any decision about teaching science, we should pose certain questions to ourselves, such as, why do we teach them science? What are the goals and objectives of teaching science? What changes does science teaching bring about in the behavior of the students? Before answering these questions, let us first define goals and objectives. A goal is the ultimate target in life which an individual tries to achieve. Goals are basically long-term, which require a long period of time to be achieved. For example, development of scientific attitude, to become a responsible citizen, etc. Whereas, objectives are short-term targets which are specific and could be achieved in a single day or single hour. For example, acquiring knowledge about some specific things within a pre-specified time limit would come under the purview of objectives. Students are potential human resources required to be developed into educated, sound, skilled and efficient citizens who will fulfill the aims of social, economical, political and technological development of the society. The aim of education is to provide opportunities for personal all-round development of individuals, to equip them with latest and sound knowledge of science and technology, and also to make them capable of using science and technology for the betterment of human society. 1.4.1 Goals Aims for Science Teaching. Considering the individual teaching and his own reason for teaching science, it would become impossible for any educational system to provide facilities for each teacher to achieve his her goals. Therefore, goals are decided at the national level. Various commissions and committees on education had been set up by the government of India after independence, which emphasized the importance of teaching of science from the primary level. All of them emphasize the teaching of science for the development of process skills like observation, classification, measurement, communication, etc. Acquisition and understanding of knowledge, development of problem-solving skill, skill of investigation, ability of think logically and to draw conclusions on the basis of experiments, development of ability to reach generalizations and to apply them for solving every day problems, development of understanding of interrelationships of science and society, to foster creativity in people, enabling them to carry out innovations in science. National Science Foundation, Washington also set the following goals for science and mathematics teaching under its Project 2061 during 1988-89. Goals for science instruction under Project 2061, NSF. Washington. Goal I, science must enlighten equally learners' personal development tilde T. This could be achieved when children will understand and use new ideas and scientific information to improve their lives, develop skills to support scientific inquiry, develop problem-solving skills needed to respond to a changing society and environment, develop a positive attitude towards science that will encourage continued interest and learning, develop the attitude and skills they need to become responsible consumers. This goal focuses on ways to enhance students' personality, their curiosity, honesty, self-confidence, ability to make decisions, examine values, reason logically, and practice the ethics of science. Goal 11. Learner must understand the interrelationship of science, technology, and society. Under this goal, the learners will be able to understand the interaction of science, technology, and society. Recognize that solution to one problem can create new problems and that decision must consider the possible consequences for other community members. Recognize that data may be interpreted differently by different people depending on their values and experience. Recognize how the advancement of science and technology has changed the lives of people in local, national, and global communities. Poses a sense of custodianship, collective responsibility for the environment over a period of time as the need for conservation increases. Goal IGNOU, science must develop each learner's academic and process skills. Science instruction should help the learners to develop a knowledge and understanding of scientific principles and concepts. Develop attitude, values, ethics of science to use as a basis for science-related decisions. Learn to think critically, creatively, and rationally so that they can solve problems and promote lifelong learning. Develop process skills so that they can think scientifically. Develop psychomotor skills so that they can properly manipulate, handle equipment and instruments. This goal concentrates on what children need to know to become scientifically literate. The curriculum must include the knowledge, concept, principles, and ideas of science, as well as the attitudes, values, and ethics of science, and critical thinking and problem-solving skills. Goal 4. Science must help to expand each learner's career awareness. This goal focuses on learners' ability to realize that science and technology are relevant to all fields of employment. Develop an awareness of occupational and professional opportunities in science for women, minorities, and handicapped. Develop an awareness of science requirements for occupations and professions. Recognize that scientists and technicians possess a full range of personal characteristics and should not be stereotyped. Develop effective and positive work habits related to science. Become informed about the contribution scientists make to society. These goals of education are intended to be achieved by the time pupils leave the school and enter the society as responsible and efficient citizens. During the school years, they are in the process of developing the personal, social, and intellectual aspects of their personality. However, it is necessary to see that the development is taking place in the right direction. In order to monitor the process of development, short-term objectives of teaching have been framed by educationists in all societies, keeping in view the requirements and nature of individuals as well as that of discipline towards progressive development. The most important and widely accepted contribution in this direction is that of Bloom and his associates. 1.4.2 Bloom's Taxonomy of Educational Objectives. Bloom and his associates developed a taxonomic model of educational objectives. They adopted a division corresponding to three primary aspects of pupils' growth, viz. Cognitive, affective, and psychomotor. Within each domain, he arranged the objectives in logical and psychological order, i.e., the sequence of the development of mental abilities has been maintained. Cognitive domain. The cognitive domain represents the intellectual component of human life. It is the most important aspect with respect to education. You will appreciate the sequence in which these mental abilities are classified under this domain. These are as follows: knowledge comprehension, application, analysis, synthesis, and evaluation. A. Knowledge. Memory or remembering is the lowest level in intellectual structure model. Knowledge involves the recall or recognition of specifics, universal, pattern, structure, etc. For example, recalling the names of animals, recognizing them as herbivorous or carnivorous, recalling their food habit, type of food they eat and type of teeth or alimentary canal they have. B. Comprehension. Comprehension is a higher level to knowledge but is also the lowest level of understanding. An individual is expected to go beyond the level of recall and recognition. Pupils should be able to understand the meaning of the concepts, to describe a process. For example, relating the type of food with the structure of teeth or alimentary canal of herbivorous or carnivorous animals, or describing the process of raining by relating the concept of evaporation and condensation. C. Application. While in application, an individual is expected to use his knowledge and understanding of the facts, concepts, principles, ideas, or procedure in a particular situation in order to solve any particular specific problem. For e.g., selecting the food for their pets. D. Analysis. It is the next higher level of cognitive ability. Here, an individual is required to analyze a meaningful statement into its various components. Pupils should be able to identify the concepts and their interrelationship in the statement. Analysis will lead to establish the relationship between various statements in a meaningful communication. E. Synthesis. It is a complex ability at a higher level of cognition. It involves the ability of an individual to put together the elements or parts in a way that a new pattern emerges out. It is an ability to give new shape or structure to statements or procedures. It has an inherent element of creativity. F. Evaluation. The highest level of cognitive structure is the ability to evaluate or judge. It is also the most complex ability since it involves all the other abilities. It enables a person to judge a material product or process against a standard and to establish the worth of it. All these abilities in the cognitive domain are arranged in a logical order. Application of knowledge is not possible until an individual has a sound understanding about the material and the process to be used. Also, for developing this understanding, knowledge is a prerequisite. Affective domain. There is another important aspect of human nature which includes the interests, likes and dislikes, feeling, behavior and attitude, etc. Psychologists have tried to identify and arrange three qualities in a gradual manner like cognitive abilities. These qualities are classified under the category of affective domain. These are the behavioral abilities which lead towards the formation of attitude, the complex and ultimate behavior norms. These are as follows. A. Receiving. It is the lowest level in the affective domain which helps in the development of attitude. Receiving is an ability of an individual to receive information from outside source. Attention of an individual is an indication that he/she is ready to receive information. Awareness of the sources of information and willingness to receive the information are the sublevels of this category. For example, awareness of Science Center 1, Information Center, Library, Video Library, etc. In the neighborhood. B. Responding. Regularity in attention and motivation leads to responding. This ability is represented by interests. Interest in a tendency to respond to a particular object situation. For example, visits to Resource Center for collecting reading materials, obtaining membership of centers. C. Valuing. The next level towards behavior formation is achieved when an individual is able to internalize the sense of worth and identification with it. Individuals set guidelines for controlling their own behavior, acceptance of a value, preference for a value, and finally the commitment to a value are steps towards character building. Taking decision about the activities of the groups, analyzing and assessing the issue. D. Organization. An individual's behavior or attitude is not ordinarily motivated by a single or isolated value. A system of values form the complex behavior represented by general behavior. A code of conduct. There should be an organization of values for a balanced conduct. Decision about conduct in real-life situations, forming opinions about major issues in reality. E. Characterization. It is the highest level in the character building or attitude formation of an individual. The values are imbibed and the individual has a consistent philosophy of life. Set attitude basis for character building leads to personality development. Whatever function an individual performs is a result of neuromuscular coordination. As the level of coordination goes up, the action becomes more rapid, speedy, and automatic. The action abilities are classified under psychomotor domain. 5 categories have been identified under this domain. A. Imitation. It is the lowest level of psychomotor activity. It starts as impulse and may grow into an overt act with the capacity to repeat the performance. Though this ability is found in early childhood years of individuals, it is also carried over to some extent in the later years. It is also the first essential skill for training the students for practical and experimental exercises. They learn the skills first by observing other teachers performing them. B. Manipulation. It is the next higher level of motor coordination. It involves selecting certain action in preference to others, following directions, and then acting accordingly. Selection is important in manipulation. C. Precision. Precision is related with speed and refinement. It gives the learner ability to control her action in response to the requirement. Precision comes with practice or repetition of performance and hence decreasing the faults in performance. D. Articulation. On attaining the ability of articulation, individuals will be able to handle many actions together. This ability involves the coordination in action. E. Naturalization. Perfection in performance or in any action is the final level in psychomotor domain. On attaining perfection, an individual requires minimum time for completing a perfect task. His action becomes mechanical, i.e., without any conscious thinking or planning. For teaching and learning science, these abilities are very essential and need to be developed right from primary stage. One can master science only by doing it. Therefore, experimentation and measurement become the basic skills for learning science. Precision is required for exact measurement and observation. Articulation and naturalization are required in planning, designing, and performing experiments. This justifies the importance of these skills to be learned. F. Behavioral objectives. You may realize that the description of these objectives in aforementioned 3 major domains does not indicate any way in which learning of the pupils could be measured. In order to measure the learning outcomes, it is necessary to write them in such a way that they describe the change in the behavior of learner, i.e., the objectives have behavioral specifications. There are various action words or verbs used to describe the behavior of learner, which help the teacher and the evaluator to decide whether learning has taken place or not. it is not customary to describe the educational objectives for all subjects in all the three domains. Depending upon the nature of discipline, the objectives are derived from the cognitive, affective, and psychomotor domain. 1.4.3 Instructional General Objectives for science teaching. The specific objective under cognitive, affective, and psychomotor domain are clubbed into 3, 2, and 1 respectively for the purpose of formulating general instructional objectives for science teaching. These are as follows: 1. Knowledge. 2. Understanding, and 3. Application are from the cognitive domain. 4. Interest, and 5. Attitude are from the affective domain, and 6. Skills are from the psychomotor domain. By now, you are familiar with these terms. Let us now discuss these objectives as they are used for instruction purpose along with expected change in behavior of learners. Knowledge. Knowledge, as you know, is the lowest level of cognitive ability. Therefore, the first objective of teaching science is related to acquisition of knowledge by the students. It states, students will acquire the knowledge of facts, concepts, principles, processes, and techniques, etc. The behavior specification to demonstrate the achievement of this objective is that pupil will be able to recall terms, facts, concepts, principles, and processes, etc. Recognize facts, terms, concepts, principles, and processes, etc. The terms like recall and recognize are the action words which represent the behavior of individuals. This overt behavior can be observed and measured by teacher as well as by an evaluator or any observer. For e.g., if you have an objective for the unit, define osmosis, you can measure either by taking oral or written test. Understanding. The second objective of science teaching is related to the next higher cognitive ability, i.e., comprehension or understanding. It states, to develop the ability to understand facts, concepts, principles, theories, and techniques, etc. Behavior specifications of objectives are that pupils illustrate terms, facts, concepts, principles, etc. by citing examples. Express the same facts or concept in different ways by explanation. Locate errors in known situation and correct them. Compare and contrast between related terms and concepts. Classify objects, facts, or any information. Discriminate between allied substances or concepts. Identify relationship between allied substances or concepts. Identify relationship between various facts and concepts. Extrapolate for known information. Translate symbolic statement into verbal statement and vice versa. Interpret data, charts, graphs, etc. Detect errors in faculty statements. Verify facts. Solve numerical problems. Application. As you know, the essence of teaching learning is the application of knowledge. You perform various activities or solve many problems in your daily life. You are able to do this only because you have the knowledge and understanding of things around yourself. The third objective aims at using knowledge in new situations. It states, to develop the ability to apply knowledge of concepts and principles of science in new or unfamiliar situations. Behavior specifications of the objectives are that the pupil will analyze situation or problem, formulate hypothesis on the basis of observation, select appropriate methods and material for testing the hypothesis, give reasons for happenings, draw inferences, conclusions, and generalizations, predict results or happenings on the basis of known facts. Skills. We know that science is learnt by doing. Therefore, for learning science, various skills are required for performing activities and acquiring knowledge. Also, type of knowledge, which has to be acquired by an individual, also depends upon the processes applied for acquiring it. The fourth objective of teaching science states to develop observational, experimental, manipulative, and drawing skills. To demonstrate the acquisition of skills, pupil will handle objects, material, instruments, specimens, and apparatus properly. Clean apparatus and instruments carefully. Observe and record relevant data accurately. Measure weight, volume, temperature, pressure, and other dimensions accurately. Put articles in proper order and place. Draw and label neat and appropriate diagrams. Make graphs and charts from given data. Improvise apparatus. Dissect neatly. Take precautions. Interest and appreciation for science. Why have you studied science? It was because you liked it, you enjoyed studying it, your curious nature got satisfied by the answers given by science. Now, you want to develop the same interest and appreciation for science among you students. Pupils learn only when they enjoy the subject and appreciate the fruits of science for the development of society. So, our next objective states to develop the power of appreciation of the developments in science and to create interests in learning science. The behavior specifications, which will be demonstrated by the students on achieving the objectives, are that the pupil will be able to show thrill and excitement while performing science experiments, feel satisfaction in collecting and exhibiting the materials, objects, specimens, and the pictures showing development of science, enjoy performing experiments in chemistry, read scientific literature, read with interest about the achievements and sacrifices of great scientists. Take part in scientific debates, discussions, and functions. Explain interdependence of organism and environment and of organisms themselves. Collect materials and specimens. Preserves materials, leaves, flowers, insect stones, and minerals, etc., properly. Visit places of scientific interest on his own. Contribute articles on topics of scientific interest. Join scientific hobby clubs. Improvise models and apparatus. Scientific attitude. We aspire for the development of scientific attitude in our students, which is the ultimate aim of science teaching. You will also agree that if we teach science properly, i.e., through activities performed under the supervision of teachers or allow children to perform unsupervised activities on their own, then surely they will adopt scientific process for learning their environment. Through guided and self-learning, they will acquire the behavior and attitude which we call as scientific attitude. On acquiring scientific attitude, pupils will demonstrate the following behavior. They will respect the teacher. They will have a keen desire to know how and whys of any event or phenomenon. They will not ignore any detail even if it is of no direct relevance of the work in hand. They will record, report, and interpret their observations honestly. They will not accept or reject anything without valid reasons. They will suspend judgment till it is repeatedly confirmed. They are unbiased in their approach to problems. They are willing to consider new ideas and discoveries. They will admit their mistakes unhesitatingly. They will develop independent thinking. They will show a spirit of teamwork, self-help, and self-reliance. Science in school. Curriculum. They are prepared to face hazards on their investigation. 1.5 Science Curriculum. In the previous sections, you have studied about the nature of science and objectives of teaching science. Now, you are in a position to define science and also able to tell the reason to why we teach science. We have set certain objectives for teaching science in order to mold the behavior of children in a desired direction. These objectives are classified under cognitive, affective, and psychomotor domain. They cover the intellectual, behavioral, social, moral, personal, and physical, and manipulative skills, aspects of human development. Now, the question arises as to what should be taught to the students and what experience should be provided to them so that they can display the expected behavior. Whatever content and activities we use apply to achieve our objectives form the part of curriculum. It includes content, subject matter given in the textbooks, learning experiences through laboratory work, learning activities performed in science clubs, learning experiences due to peer and community interaction outside the classroom, learning through pupil-pupil interaction in the classroom, learning through pupil-teacher interaction, etc. Hence, curriculum spells out the total experience pupils have in schools through classroom activities, laboratory work, playground experiences, interaction with teachers and peers, inter-school and inter-class academic and cultural activities. We know that children are individuals with their own intellectual and biological needs, capabilities and potentialities. Therefore, every aspect of their need and development should be taken care of while framing curriculum for them. Simultaneously, we have to take care of demand for scientific and technological developments for our developing nation. These demands are to be fulfilled by the younger generation when they enter the society as responsible citizens. Another important aspects of curriculum are the subject matter or the medium through which these demands of the child or society are to be fulfilled. Now, the question arises as to how to plan a curriculum that caters to the needs of pupils, society as well as that of disciplinary subject matter. There are some principles for constructing the curriculum. Let us examine them. 1.5.1 Principles of Curriculum Construction. Principles of child-centeredness. Foremost, consideration should be given to the child. We know that children's cognitive abilities develop with a preset sequence. A child is a growing human not only intellectually, but also physically, emotionally, morally, and socially. It becomes obligatory on the part of curriculum planners to provide means and material to satisfy the child's need for proper growth and development. 2. Principles of community-centeredness. We know that children are an asset of our society. No society can possibly be completely developed and perfect. There is growth-added development in every society. For development, it needs human resources as well. The requirements of society have to be fulfilled by educated citizens. Planners foresee the needs of the society in the form of teachers, doctors, engineers, skilled and trained personnel in different fields, scientists and technicians, etc., as required by the society. So, the curriculum should be so planned that it could equip the children with knowledge and competences expected for them by the society. 3. Principle of integration of science. As you know, that the later half of the 20th century saw the explosion of knowledge. Knowledge is accumulating at a much higher rate than ever before. This expansion of knowledge is there in every discipline, especially science and social science. The things which are relevant today may become obsolete tomorrow, i.e., by the time children will come out to schools. You also know that science has a distinct structure, and within this framework of structure, new knowledge is accommodated. Science has three main branches viz. Biology, chemistry, and physics, and all the three are equally important for learning and exploring the environment. In actual life situation, we cannot separate the three. There is a component of all the three sciences in whatever we observe, e.g. food, water, air, plants, animals and other non-living things. Imagine anything and think about the chemistry, physics or biology involved in it, or find out the relation of at least two of them. Take an example of air. The constituents of air we study in chemistry, its pressure and movement are studied in physics, and it is also essential for life, used in respiration, therefore. We also study it in biology. Similarly, other examples could be food and water. So, in order to highlight the integrated nature of science, all the three subjects should be taken as general science, integrating the discipline, especially up to secondary stage. 4. Principle of integration of the needs of child, society, and discipline. You may realize the difficulties faced by a curriculum planner, as they have to justify the needs of child, society, and discipline. What we can do is to integrate the requirements of the child, society, and subject matter in the best synchronized form. At each level of planning, we should keep in mind all the three aspects. Principle of creativity. Have you ever seen a normal, healthy child sitting quietly and doing nothing for most of the time? Possibly not, because children by nature are very energetic. They are always active when they are healthy. If you observe the children's activities, you will find that many of them are very creative. To keep this ability alive, there should be a conscious effort on the part of planners, so that this creativity can be nurtured. This aspect will help the child to try out new methods and techniques when he will be in actual field of work in the society. It will help him to take part in the development of society. Therefore, curriculum planner should give enough spaced freedom for creativity. 6. Principle of activity-centeredness. We know that children learn science best only when they do it, as they are intellectually and physically in contact with material of science. Simple scientific activities performed in the classroom, in laboratory, or at home enable the child to go beyond the verbal information and also give them confidence that they can deal with it. This aspect of learning is being kept in mind while developing the curriculum to make activity-based curriculum. 7. Principle of flexibility. Ours is a diverse society. India is a large country, apart from human variations in terms of culture, occupation, social and economic conditions, religion, castes, rural, urban, etc. We also have difference in geographical conditions. It is impossible to set a rigid national curriculum for our country. Also, the knowledge is changing with such a rapid rate that every year, new discoveries are either replacing old knowledge or improving it, so it is necessary to keep the curriculum flexible in order to make it effective. 8. Preservation of culture. We know that culturally, India is a very rich country, and over the years, people of India have preserved it. Education is an important medium through younger generation have got glimpses of an extremely varied culture. The values, morals, attitudes and customs which are part and parcel of culture have to be preserved and concerned. We have mentioned some major issues which have to be considered by the planners while framing the curriculum for secondary schools. 1.5 Science education in India. 6. Now let us examine some of the efforts put into shaping science education for Indian schools. Science as a separate subject was included in school curriculum in the beginning of 19th century. It was then referred to as general science. After acquiring political Independence in 1947, Indian government set up the University Education Commission under the chairmanship of Dr. Radha Krishnan in 1948. Through the commission was to report primarily on university education, it made valuable suggestions for secondary education also. The commission recommended inclusion of general science as a course of study in secondary schools. During 1947 to 50 to the system of basic education, accepted as a national system of education, visualized the general science approach to teach science at elementary stage. Mudaliar Commission 1953. The first genuine attempt for making teaching of general science as a compulsory subject in secondary school was made in the recommendation of the Report of Secondary Education Commission 1953, Mudaliar Commission. The commission suggested compulsory inclusion of general science at middle and secondary level. It also suggested diversification of courses having science group subject as optional channels at higher secondary level. A thorough discussion on all aspects of science education, with syllabus, equipment and materials, teaching aids, textbooks, science clubs, museums, and methods of examinations, etc., was held at All India Seminar on Teaching of Science in Secondary Schools held at Tara Devi in 1956. It had suggested a uniform system of science education for the entire country, suitable to its needs and resources. It had also suggested organization of content of science under I. Environment-centered topics, 2. Life-centered topics and 3. A combination of both to bring about integration among the various branches of science. The major and minor concepts should be related to facts and events of everyday life, include necessary practical work and outdoor activities. In 196-1, the Government of India established the National-1 Council of Educational Research and Training to look after the school education. In 196-1, the Indian Parliamentary and Scientific Committee was set up. The committee took up the study of science education in schools. The committee found a gap between what was being taught and what ought to be taught. The Department of Education in Science and Mathematics in Insert undertook the responsibility of development of science and mathematics curriculum at secondary level. A team of experts from UNESCO arrived in India to advise and assist restructuring science education at school level. They suggested experimentation and inquiry-based teaching methods to improve science education. Kothari Commission -1966. 111. The meantime, the report of the Education Commission, 1964-66, under the chairmanship of Dr. Kothari was also published. The Commission recommended that science and mathematics should be taught on compulsory basis to all pupils as a part of general education up to first 10 years of schooling. It recommended that at lower primary classes, science teaching should be related to child's environment. At upper primary level, emphasis should be on acquisition of knowledge, ability to think logically, to draw conclusions, and to make decisions. At lower secondary level, science should be developed as a discipline of mind. The newer concepts in physics, chemistry and biology, and the experimental approach to the learning of science should be stressed. Science teaching should be linked to agriculture in rural areas and to technology in urban areas. The method of teaching science should be modernized, stressing the investigatory approach and understanding of the basic principles. The method of teaching science should be modernized, stressing the investigatory approach and understanding of the basic principles. Guide materials should be made available to help teachers adopt investigator approach. There should be flexibility in the curriculum in order to cater to the special needs of the gifted children. As a follow-up to the report, a top-level conference on science education was convened. Under the chairmanship of Dr. Kothari, it was held to plan an effective program for the development of total curriculum of science education at different stages. The Ministry of Education and Social Welfare appointed an expert group in 1973 to develop curriculum for 10 plus 2 pattern. The curriculum for the 10-year school of framework, published by INSERT, was developed by the expert group under the chairmanship of Professor Rais Ahmad. This model curricula recommended the school science to be taught as environmental studies at primary stage and as integrated course at middle stage. A review committee was appointed in 1977 under the chairmanship of Shri Ishwar Bhai Patel. The committee suggested the strengthening of abilities under affective domain through curriculum. The curriculum should not be too bookish. 10 plus 2 system of school education recommended by Kothari Commission became the national system of education. Science curriculum, as you will find, are always developed keeping objectives and national development goals in view. These courses are designed by INSERT at national level for various stages of school education. The new framework document of the 10-year school, titled National Curriculum for Primary and Secondary Education, a framework developed by INSERT, is a forerunner of the National Policy on Education 1986. INSERT develops its courses through various workshops and seminars in which academicians and experts from various institutions take part. Personnel like school teachers, subject experts from colleges and universities, teachers from vocational and professional institutions, teacher educators, state representatives, and experts from INSERT also take part in curriculum construction. Experts review these curricula periodically and make it up to date. 1.6 Summary. In this unit, you have learned about the nature of science and how children learn science as both process and product. The processes of science are skills required for learning science. There are 6 basic processing skills: observation, classification, communication, measurement, estimation, and prediction. With the help of these basic skills, individuals acquire problem-solving skills, which are also called as integrated skills. There are 7 integrated skills, viz., identifying and controlling variables, defining operationally, forming hypothesis, experimenting, tabulation and graphing, interpreting data, and investigating. These skills equip the individual with the ability to explore and learn about his physical and social environment. The knowledge or information an individual acquires through these processes form a product of science. The depth, and authenticity of the knowledge acquired by individuals depend on the processes applied by them. The product of science comprises of facts, concepts, principles, theories, and laws. The second part of the unit dealt with the objectives of teaching science. The definitions and differences of goals and objectives were given in the beginning. Goals are ultimate targets, aims in life which individuals want to achieve and are general in nature. These are long-term objectives as they need a longer period to achieve. Objectives, on the other hand, are very specific targets to be achieved in short duration of time. The emphasis given to science education by various commissions and committees were discussed. The common emphasis was on the following: development of process skills, acquisition and understanding of knowledge, ability to think logically, reach generalizations and application of knowledge, understanding related to the interrelationship of science, technology, and society. The goals set up by National Science Foundation, Washington for teaching science were discussed. There are four major goals: 1. Personal development of learner. 2. Interrelationship of science, technology, and society. 3. Development of learners' academic and process skills. And 4. Expansion of career awareness. The taxonomy of educational objectives, as given by Bloom, was also discussed. Bloom classified the objectives under three major domains: viz., cognitive, affective, and psychomotor. There are 6 objectives under cognitive domain, which are knowledge, comprehension, application, analysis, synthesis, and evaluation. 5 objectives under affective domain deal with the abilities like receiving, responding, valuing, organization, and characterization. The psychomotor domain comprises of the abilities related to the action or manual work, like imitation, manipulation, precision, articulation, and naturalization. On the basis of this classification, the general instructional objectives were designed. They are structured as knowledge, understanding, application, skill, interest, and attitude. The behavior specifications for these objectives were discussed. The third part dealt with the meaning and basis of curriculum. The principles of constructing a curriculum are as follows: 0. Conservation of culture. 0. Discipline-centeredness. 0. Principle of creativity, flexibility, child-centered. The efforts of various commissions and committees in defining and framing national curriculum with emphases on science education were highlighted. In the end, it was mentioned that people from various fields of society take part in framing the curriculum under the guidance of national framework. NCERT is the national institution which delivers the responsibility of preparing curriculum for various stages of school education. Thank you.